Okay, the actual instruction says determine the number of triangles with the given parts and solve the triangle. So not only do you have to determine how many different triangles there are, you have to go a step further and solve it. Now these three are set in stone. These three are given to you. We can actually use these three to very easily find angle C. Because we have angle B, side B, we have side C, and you can use law of sines to find angle C. So we have sine of beta over B is equal to the sine of C, or gamma, if you want to put it, over C. From the law of sines, again, you have a proportion. Multiply these two and divide by 15.9. I got 0.4065, so now you have the sine of C is equal to about 0.4065. Now here's where you determine how many triangles you have. When you move the sign over and do inverse sine of that answer, second sine of the answer, I get that C is about 23.98 or 0.99. I'm going to leave it like that, 23.99 degrees. I do want to remind you that's not the only answer. You have a first quadrant answer of this 24 degrees. But not only do you have a first quadrant 24 degree, but you have a second quadrant possible that has that same reference angle, which would be, let's see, if this reference angle is 24, that would be 156 degrees, I believe. And you can check that. The sine of 24 or the sine of 156 is the exact same thing because they have the same reference angle. They're both positive because, again, sine represents a y value, and in the first or second quadrant, your y values are positive. So these 2 points will have, on a unit circle, will have the same y value. So 24 degrees or 156 degrees, but look at the problem. Could angle C be 156 degrees? If you've got a triangle and angle B here is 130.5 degrees, is there any way possible that you can have another angle in that triangle that's 156? No. So 24 is going to be the only, or 23.99 here is going to be the only possible angle. So there's only one triangle possible. If both of these would have worked, then there's going to be 2 triangles possible. If for some reason you get something like the sine of C is equal to like 1.4, and we know that when we take the inverse sine of that, we should already know that sine can't be bigger than 1. It can't be smaller than -1. So before you even take this, you're going to get an error. So anytime you get an error on something like that, that would mean that you have no solutions to it. Okay. Here's number 16. It says, what is the length of a chord? And a chord, if you don't remember from geometry, a chord is any line segment who has endpoints that are on a circle. This is the actual chord right here that they're asking about. What is the length of a chord intercepted by a central angle of 16 degrees? So this is a 16 degree angle here that has a radius of 25. So these are both 25 because in any circle, this radius and this radius is going to be the same length. This is going to turn into either a law of sines or a law of cosines problem. If you want to use a little bit of geometry, you could actually do it with law of sines. This is how I'd work it, because I want to go back and review some geometry with you. 25, 25, 16 degrees, because you didn't see a lot of this in geometry. This is an isosceles triangle, and anytime, bless you, anytime you have an isosceles triangle, if the sides are the same, the angles are the same. So if this is 16 degrees and the 3 have to add up to 180, that means that these 2 have to add up to 180 minus 16, which is 164, which means it's 82 degrees apiece. You didn't have to do this. You can use law of cosines to solve this, but this, to me, this way is a whole lot easier. Because now in order to find that chord, which we'll call x, you can simply do the sine of 82 over 25 is equal to the sine of 16 over x. If you solve it, again, if you want to solve it the law of cosines way, okay, this is one way to solve it. The law of cosines says this. A squared equals B squared plus C squared minus 2BC times the cosine of A. So law of cosine, this would be the angle. This is, in your formula, we don't have any A, B's, and C's, but the angle that you're given will always be this angle here. The one that we're given is 16 degrees. So that makes little a unknown, and it makes B and C 25 and 25. You have A squared equals 25 squared plus 25 squared minus 2 times 25 times 25 times the cosine of 16 degrees. Make sure on law of cosines that last step, so to get rid of the square, you're going to have to square root this whole thing. I solved it this way. Again, 25 times sine of 16 divided by the sine of 82. I got that x was about 6.96. And if you solve it this way, you should get the exact same answer. Let's see. And I do. Again, make sure that you square root at the end, but the square root of all this gives you that exact same 6.96 as an answer. So either way that you work it, the chord is equal to 6.96. Okay, this is number 8. Again, here's the drawing. Some of you might be having trouble with the drawing, but it says the angle of elevation to the top of a tower. So here's your tower here. From point A on the ground is 16.3 degrees. So here's point A, 16.3 degrees. And then it says from point B, which is 35.8 feet closer. So you're walking closer is what you did. So 35.8 feet closer. That's just the distance from A to B. Your angle of elevation is 19.7, which makes sense. If you walk closer, then you're going to be looking more straight up towards it. And we want to know if that's the case, then how tall is the tower? Okay, here's what we're going to do. If this is 19.7, we're first going to take this triangle here, this oblique triangle. Let me redraw it separate from the other. This is a 16.3 degree angle, and here's, actually, I got tripped up on it the first time I worked it because of this. 19.7 is the angle of elevation. If you're looking forward, that's a 0 degree angle. But then you look more up into the air, and that's the angle of elevation. This is the 19.7. This is not inside this oblique triangle. If this is 19.7, do you remember linear pairs? These, since they form a straight line, these two angles have to add up to 180. That makes this angle 160.3. I believe that's right. If you subtract the 19.7 from 180, this is 160.3 degrees. And we know that this is 35.8 feet. What you're going to do is you're going to use these angles. You're actually going to have to use all three. And I want to know what this is. And you'll see why in just a second. So first step, find the distance from A to the top of the tower. This distance, which I've labeled as X here. In order to do that, we're going to need, well, here's the side length I have. In order to use law of sines, you're actually going to have the angle across from it, which we don't have, but which we can find. On these problems, one of the most missed things about them is thinking that you don't have this third angle here. If you've got these two, then you've got that one as well. Add those two together. That gives you 176.6, which leaves you with 3.4 degrees, I believe, which is a very tiny angle. So we're going to use this information and the law of sines. The sine of 3.4 over 35.8 is equal to the sine of 160.3 over x. Solve it like a proportion. I get x is about 203.49. But what you're going to want to do, we're fixing to use that. So you're either going to need to store it, or from what I told you yesterday, write down as many decimal places as you can. It's actually 203.4858, 907, which is much better to store into your calculator than to do this way. That is this value. Now, the whole purpose of having to do that, I want to show you the big picture. You're looking for the height of the tower. I'm going to call it h. You can now ignore this line and go to the big picture and use basic SOHCAHTOA. The difference between what we're doing now with law of sines and law of cosines and the SOHCAHTOA is law of sines and law of cosine works on oblique triangles. Well, it really works on any triangle. If you've got a regular right triangle, that's when we just use SOHCAHTOA. Sine equals opposite over hypotenuse and all that. We now know that this is 203.49 rounded. We know that this is a 16.3 degree angle, and we know that this is the height that we're looking for. Okay, so here we go. Basic SOHCAHTOA now. In order to find the height, since we have this is opposite and hypotenuse, so you're going to say the sine of 16.3 equals opposite over hypotenuse. And hopefully you see now why I'm saying don't use the rounded. Okay, use this more exact in order to find h. Multiply sine of 16.3 by that 203.49, which luckily I still have the exact on my calculator. Don't ever clear it if at all possible. So I've just got to take this answer and do times the sine of 16.3. Make sure you're in degree mode, and you get right at 57.11. So the height is right at 57.11. And I believe that was in feet.